Hello, and welcome to today's ACM Tech Talk. This webcast is part of ACM's commitment to lifelong learning and professional development, serving a global membership of computing professionals and students. I'm Lori Williams, a distinguished professor of computer science at NC State University. I'm also the co-director of the NC State-based Science of Security Lablet, sponsored by the NSA, and the co-director of the NC State Secure Computing Institute, and the chief cybersecurity technologist of the Secure America Institute. My research focuses on software security and agile software development, particularly continuous deployment and software reliability. I am an ACM member and an ACM distinguished scientist. For more about my background, there's a bio widget on your screen. For those of you who may be unfamiliar with ACM or what it has to offer, here is more information. ACM offers educational and professional development resources that bolster skills and enhance secure career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. You can see some of the highlights on your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. ACM provides access to the ACM Digital Library, the world's most comprehensive database of computing literature. Provides leading publications and global conferences that draw top experts on a broad spectrum of computing topics. ACM supports education and research, including curricular development, teacher training, the ACM Turing and ACM Prize in Computing Awards. And finally, ACM has a code of ethics, a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions in the professional practice. ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Before we get started, I'd like to quickly mention a few housekeeping items shown on the slide in front of you. If you are experiencing problems with the slides or audio, refresh your browser or close and relaunch the presentation as the first line of defense. If you have any questions during this talk, please type them into the Q&A box at any time and click the Submit button. I'll organize the questions as Michaela speaks, and she'll reserve time at the end of the presentation to address them. This session is being recorded and will be archived. You'll receive an automatic email notification when it becomes available. And check learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey on your screen. Please take a minute to fill it out to help us improve Tech Talks. You may also open the link to the survey at any time from the resources window. You can use Facebook and Twitter widgets on the bottom of the panel to share the presentation link with your friends, as well as to tweet comments and questions using the hashtag ACM Learning. We'll be watching for your tweets, and we'll be adding them to the Q&A queue. We also have a community Discord page to continue the discussion after this webcast, including questions we won't be able to get to. Today's presentation, Code Reviews from Bottleneck to Superpower by Michaela Greiler. Over the last 10 years, my friend Michaela extensively researched and developed test, build, and code review techniques and tools that boost the efficiency and effectiveness of engineering teams. She worked with all major product teams at Microsoft, such as Windows, Office, and Visual Studio, which is where I met Michaela. Since starting her own consultancy and training business, she works with engineers around the world and companies such as National Instruments, Metro Systems, Wix, Blip, and many others to help engineers boost their code review practices. Michaela has a PhD from Delft University of Technology and Software Engineering and received the Google TechMaker Award. She also runs the Software Engineering Unlocked podcast, so check that out. Her research is published in several high-ranked scientific journals and conferences, including plenty from ACM. Michaela, without further ado, take it away.
Thank you so much, Lori, for this really kind and very, very nice introduction. I'm very flattered. And I'm really, really happy to be here and talk to so many people and talk to the ACM audience about my favorite topic, which is code reviews. As you said, over the last 7-8 years, I'm really specializing on code reviews. I did several research studies. I worked with engineers at Microsoft. And so I'm really happy to share my knowledge that I gained on code reviews with you today. I'm going to share my screen so that you can actually see my slides. So. Okay, good. So, as Lori already said, the presentation is called Code Reviews from Bottleneck to Superpower. And so what I want to discuss with you today is some of the problems that we see with code reviews and some of the benefits that we can actually get. And code reviews are very well known for all of their benefits. So when we hear about code reviews, we hear about collaboration. We hear that people are finding bugs because of code reviews. We hear that, well, there are code improvements made in the code base, right? You have a more coherent code base. We have teams that get more awareness. They know what's going on. We have others, engineers that learn from each other, that mentor each other. And accident prevention that's happening. Maybe we even use tracing and tracking functionality of our code review tools. And so there are tons of benefits that we actually get out of code reviews. There's a lot of motivation to go into that. And it's not only all hearsay. It's not only anecdotal. There are also studies, and I just listed a few of them, that show that, well, we have some scientific evidence even that code reviews are helping to reduce defects, that code that is reviewed has less bugs left. There's even a recent study from Bajeli and Sadowski, which shows that 80% of the code reviews lead to code improvements at Google. And there are also other studies that are not only focusing on finding bugs, but also on the other aspects. Like we see that there's increased knowledge sharing going on in code reviews, that there is mentoring and learning actually happening, that we have these team awareness benefits that we are getting out of it. And so I think because of that, a lot of companies hopped on this code review wagon. And I would say it happened so over the last 10 years that code reviews became really, really popular. But there was also a different development that helped to get code reviews this popularity. And that was that the pull-based development model became really widely used. So there are platforms like GitHub, GitLab, Bitbucket, which allow, well, versioning control. They also allow hosting of your code, but they also have a natively integrated pull request or merge request feature. So what's that? Well, it means that if you're working with Git, which is very, very popular right now, you can actually branch off from your main branch and do your work in a different branch in isolation. And then instead of pushing your changes, you're actually pulling, others are pulling your changes in. And so this pull-based development model became very, very popular, is very, very popular, but it also means that suddenly you're creating this moment where you're taking in code of other person. And so what are you doing? Well, you're looking at the code, you're seeing, well, what's actually happening here? What does this change do? What's the quality? Should I pull this in, right? Because suddenly you have responsibility of the code of another person. And so boom, what happens is that you have a lot of companies that are adopting those tools, very popular tools, and adopting those pull-based development models, and they're all doing code reviews. So now they're all doing code reviews because it's there, it's based on this development model that we are having. And so now we are expecting all of those benefits. And so what we envision is that we have like all these happy companies all around that are using Git, GitHub, GitLab, and other tools, right? And code reviews are also the barrier to entry became even lower because it's not only those platforms, but it's also the IDEs that support them out of the box. So code reviews are now, it's not really hard to get started with them. But now, if you look a little bit closer, and you don't have to look too close, we see that there are a lot of teams that are actually unhappy with these engineering practices. They are not getting the benefits that they hoped to get from code reviews. In fact, it could be that instead of improved code quality, mentoring, and learning, they get delays in their code velocity. They receive low quality or maybe questionable feedback, and they even have to wait for quite some time to get that feedback. In the worst case, we see power struggles and also toxic team dynamics really surface in the light of code reviews. So the question is, what's actually going on here? Are code reviews a scam? Are they not providing those benefits, or what's actually happening? And there are really a lot of different problems. I work with dozens of teams, with hundreds of engineers all over the world. And what we see is that the pain points are manifold, right? So there's like people are waiting for the code review feedback. They are interrupted by code reviews. There are large reviews that are difficult to review. They have like maybe low feedback quality, as I said, bullying, feeling attacked, and so on. But if you really look what's behind that, I think the fact, the truth, the harsh truth also is that teams and organizations are not prepared to do code reviews. Code reviews are a socio-technical engineering practice. And as such, they are actually, the developers need a broad range of skills to do them in an effective, in an efficient, and in a satisfactory way. What does it mean? Well, you have to have social skills like communication skills. It's also written communication. I will talk about this a little bit later. You have to have conflict resolution skills. You have teamwork and collaborative skills to have effective and beneficial code reviews. And then you have the technical side. So it means that you have to know a lot about the technologies that you're working with, the best practices. You also have to have the ability to read, understand, and evaluate the code of others. And we know that reading code is actually something that developers do quite a bit. It's actually the majority of time that engineers spend is spent on reading and understanding code. But still, let's think about how many techniques do you know that teach you how to read code? How many techniques, how many trainings, courses do you know that help you to understand how to do code reviews? And if we reflect that or compare that with testing, for example, we see that there's a big differentiation, right? There's tons of resources out there that help you to become a good tester or to increase your testing skills. And we know, be it manual testing or even automated testing, we need a strategy. There are different strategies that help us find different errors, different defects. And we also know that developers out of the box, they are not the best testers. They are mainly testing the happy path and that's it. But for code reviews, no such trainings or really limited trainings exist. And very similar, it's not only the engineer, it's also the organization, right? So the organization now have somehow access to features, to code review features, because they are readily available in their IDEs, in their development environments, in their versioning control or code hosting platforms. And so they are using them without being really prepared to also change or integrate that into their own development processes and development environments in such a way that it's effective and efficient. And so today I work really with a lot of companies over the last years. Today I more or less show you my secret sauce for successful code reviews. And so it's actually a 3-pillar recipe, right? So the first ingredient for it is you have to have better communication. It's really the main foundation for good code reviews. You also have to have a focus on the reviewer's success. How can you actually set the reviewer up for success? And then the third one is purpose-driven processes. And I will talk about this later. So let's look at communication. Well, there's the what and there's the how. And I like this picture. I drew it myself, and you will see it quite a bit. And so it's two people that look at one number and they're seeing two different things. And I think it's very characteristic, or it's very characteristic for code reviews, because this is actually the power of code reviews. This is what we hope to get from code reviews, that we are looking with our different backgrounds, with our different values, expertise, experiences, skills on something, and we see different things. Otherwise, we wouldn't need like this 4I principle that we ask another person to look over it. But on the other hand, this is also what creates the conflicts between people, because, well, one sees the 6 and the other sees the 9. So who is actually right here? But this will come up quite a bit. But it's also the what and the how. And this what and the how are also two perspectives on the same problem, communication. So what is all about technical perspective? The how would be the social aspect of it, right? How do I actually give this feedback? And so for the technical perspective, for the what should I actually talk about in code reviews? We see that not all code review feedback is equal. And this is a study that we did at Microsoft, where we classified over 2 million code review comments, and we observed and interviewed really a lot of engineers, and we let them classify and describe the value, the usefulness of different code review comments that they received. And we also classified them to a standard taxonomy that you see here, right? Documentation actually talks about readability of the code, maybe size of a method, the comments that we have here, right? UX design, organization. I'm not going too much into that because I want to present a lot of things here. But what we can see here is that not every category has the same usefulness to people. And especially when we come to documentation, which we also see is the majority of comments are about documentation, right? And we see that almost half of it is only somewhat useful or not useful for the code author. And we also see that very often bugs, for example, bugs make up only 15% of the code review comments are somehow related to bugs. It doesn't mean that they are finding bugs. So there's a lot of documentation discussion, and even for the other things, organization of code and resources and all of that, we see there's actually quite something going on, and it's not always useful. So what are some of the things that we found out are really useful? Well, the best code review comments are about functional defects, missing corner cases and validation, how to use an API, best practices, best engineering practices, right? And then we have like this in-between things. They are okay-ish. It's about documentation, again, readability of the code, coding styles, convention, spelling mistakes. And then we have the no-goes, which are alternatives without benefits, right? I would have done it differently, but there is no reason why we should actually change it. We're talking about existing tech debt or refactoring or planning and future work. So everything that's out of the scope of the code reviews. And so how can we make sure that we are actually giving valuable code review feedback? And this is where I want to come back a little bit to when I talked about testing. Well, we have test strategies, and actually there's a little bit research done around reading modes of code reviews, right? So everybody that nowadays does code reviews, or the majority, they do them in an ad hoc manner. This means there's no predefined way how to look at the code reviews, how you go about them. You probably open them and then people, get an overview and they click through the code. But everybody defines it for themselves. There's also, I think, another one which is more what we are more used to and which is more widely adopted. It's checklist-based code review. So you're actually having a checklist and you use this checklist. There's some questions and give you some instruction. And there's research that shows that it's quite effective, especially compared with ad hoc code reviews. And then scenarios would be even more structured, and you would really look for something for a specific scenario, for example, data type consistency or object-oriented programming or something. And so the questionnaires and the way you're looking through the code is really specified for that. Another thing which there is new research on that is test-driven code review. So you're starting to analyze the code based on the test. And there are also other ways to do that. And I quickly want to hop into, for example, the code review checklist, because somehow I think we all know about them, but are we actually using them? And I found they are a really effective tool for many things, for self-review, but also to remember that we should look at that. We don't have to read every sentence, every question while we are going through the code, but we can take it and we can, quickly look over it. And what are some of the usual things that we are looking in such a, or that are mentioned in such a code review checklist? Well, implementation, logic errors, right? Logic, error handling, usability, testability, and so on. And I actually have a written code review checklist that I often give to my code review workshop participants as well. You can find it actually on GitHub. And I think what shows here is that with a code review checklist, you can drive also behavior, and you get a similar, or you can change the rigor and the similarity of rigor in your organization, right? So a lot of organizations struggle actually with the consistency of code reviews, with the rigor that is done. So one organization or one team is doing more rigorous code reviews than the others. And so with a code review checklist, you can actually change and unify a little bit the importance of some of the aspects. And so why I show it is because very recently, I added a new section to my code review checklist, and it's about ethics and morality. And so it asks a question about, well, does this change make use of user data that might raise privacy concerns, right? Or it also asks for algorithms, especially, for example, artificial intelligence or machine learning, right? Are there some biases introduced? What have we done to make sure that the biases are, are not there, or that we are circumventing that, and so on? And why I'm showing it is because, well, by introducing something like this and distributing it through the organization, suddenly people that wouldn't have been aware of those questions could become aware of those questions. Anyway, coming back to not all code review feedback is equal, I want to show you the Maslow pyramid of code reviews, right? So probably you're familiar with the Maslow pyramid of needs, which means that, well, if people have needs, you have to first fulfill the basic needs, and then you can build up. But it doesn't matter, or it's not worth to really fulfill a very high up need if you don't have the foundations. And for code reviews, this would mean that, well, we don't want to look for things like, is the code inspiring or elegant, if we haven't looked for, is the code correct, secure, or readable, right? So you want to start at the bottom, and this is the main valuable code review feedback also for your teammates and colleagues. But even for that, there are several perspectives. So there's actually a nice discussion, an interesting discussion on Reddit going on. Even for this pyramid, people would say, well, correctness, what is correct? Code is never correct. So the first thing and the main foundation of code reviews is readability. Because if it's readable, it's maintainable, and you can change it, and change is inevitable. So this is the main important foundation of code reviews, right? And then is correctness, security, elegance, inspiring. I don't want to go deep into that. It just shows again that there are different perception. And what I really like to do with teams is to work on their engineering values, on their team values. So what are we seeing? And really having those discussions and laying out how we see the world, and also understand how others are seeing the world. And at Microsoft, we also ask people, and this is just an anecdote on the same thing, right? We ask them, so what does high quality code mean to you? And they would say, well, definitely high quality code adheres to coherent coding styles and has no spelling mistake. But the same person, right? The same participants in this survey and in this study would say, well, but don't comment on my coding styles and spelling mistakes. And the important thing here is that, again, and I will come to that a little bit later, it has to do also with the expert blind spot, but it has to do that, well, we need this feedback, right? So talking about readability in code reviews is really important. And we know that we need, that we need to spell check our code, that we have to make sure that comments are not outdated and so on. But obviously we don't want it. So we have to be extremely careful also how to phrase it. And this brings me from this technical perspective actually to the social perspective, right? So how do we talk about this? And for example, for those documentation issues, readability issues, we can, for example, mark them as nitpick. We can, again, as a team, really develop our values. We can also automate a lot of stuff, which is very, very helpful. And if you look about how to communicate, we see that in code reviews, we often have written communication, and this is especially tricky. And why is it tricky? Well, because with written communication, you don't have body language, you don't have facial expressions. We are very prone to bias. There are tons of studies that show that written communication, people are even more prone to bias than if you have face-to-face communication, or even voice. Even the voice already helps us to get over some of our biases. And then we're also doing a very technical task. We have this technical, hat on. We're looking through the code. We're trying to find technical problems, and then we're typing that comment or this feedback into a tool, which again is very technical, and we don't see this connection with this person. And I observed really tons of engineers doing code reviews, and even for the very, very experienced ones, what I see over and over again is that they are in this technical mindset. They are analyzing analytically and like an algorithm their code, and then they start typing in their comments. And what you can see is that only at the end, before they're sending and pressing the send button, they remember, oh, actually there's another person, right? And so they rephrase actually their code review feedback to make it understandable for another person. And so it's really important to keep in mind for written communication that the sender doesn't really have too much influence on how the receiver will receive the message. So the whole interpretation is done by the receivers. So this means that we have to be particularly careful. And there are a lot of things that you can actually do to make the code review feedback more friendly, more respectful. I linked one of my blog posts on that here as well, if you want to have a look. But for example, for this variable should have the name user ID, especially naming things are very, very objective, right? So we can rephrase that. We can ask a question instead of making demands. Or if we really think it should be user ID, we could give an explanation why. I could say, I think, so you're owning your feedback. And there are many, many things that you can actually improve here. You can also learn, for example, nonviolent communication, which I really like to teach in my workshops. I think it's a very powerful framework to help also with conflict resolution skills. And obviously, another social skill that you need is group decision making. But let's go away a little bit from the communication. I think there's tons of potential for improvements, for growing on this communication, in these communication areas. But the second pillar is the reviewer's success, right? And the reviewer's success means a mindset of how can we set up the reviewer to do their best, to be able to provide valuable feedback. And so if we look a little bit at research, we see that the experiences that engineers have, and there are also a lot of studies on it. This is just from one study that we did at Microsoft, but there are several studies that confirm the same thing. If the if the reviewer has prior knowledge about the file, about the code, they're doing much better than others, right? And so here we see the usefulness density. So how many useful comments out of all comments does a reviewer leave? And you see if they haven't seen the file before, haven't worked on that file before, it's below 40%. But then if they only see it once, we have like a really steep increasement of the usefulness density. And then we somehow, it plateaus somehow around five times that the person has seen this file. And very similar, it's with lines of code, so different metrics for that. But we can also see that if you're looking at valuable feedback, it has to do that the person has to know the technology, right? And so what this leads you, if you say, well, that is, setting the reviewers up to success, then it would lead you to a very bottleneck approach where you say, well, only the senior reviewers, senior developers are actually looking at the source code. This is not what I want you to do, because it's not a long-term strategy and it's not very helpful. For example, for other benefits that you want to get out of code reviews, which is, for example, team awareness, mentoring and learning, right? So you want also juniors to look at that, and you want also people that haven't seen this file before to see this file. So what can we do? Well, at Microsoft, this is another study at Microsoft, where people were saying, well, most of the time they need more information to understand the code and give valuable feedback, right? So this was really a pain point that a lot of engineers had. The flip side, and this is again why I have these perspectives here, the flip side is that even the same person would say, well, for my change, right, the change that I worked on, there is no need for a lengthy code review description. The context and the code are very clear. So what we could see is that on one hand, people needed more information to give valuable feedback. But on the other hand, when it was about their code, they felt, well, we don't need a more review description. I don't need to give more context. And this has to do with the expert blind spot that is really very, that happens frequently in code reviews, right? So you have, like, again, these two perspectives and this very unbalanced expertise, because you have one person that works maybe a day, maybe a week, on a code change, on that problem. They're very, very familiar with what they actually have to accomplish. And then you're asking another person to look at this code change, let's say for half an hour, maybe they have even an hour, but it's a very limited time window that they have to understand the code, what's going on, and then even evaluate that. And so the expert blind spot means that experts see no problem with that, right? So you worked on this code and you're so familiar with it that everything seems trivial, easy. There is no need for more information. It's very similar to if you're in a meeting and your colleague has been there as well. So we both heard actually what this feature should be about. But obviously your attention span, if it's about your own project, is very different than your attention span if there is like talk going on about the project of somebody else. So it's really important to give good code review descriptions and have templates around that help people also extract that knowledge, because it's not even easy for them to extract the knowledge and know which information should they actually provide about a code change so that others understand. But we have a lot of information on that. We have research that shows what information actually help others to understand code changes. And so if you design your process, you should make sure that this is part of your code review process. Another thing to help reviewers is the reviewer size, right? So the review size. And this is a joke on Twitter, actually. It says like 10 lines of code is 10 issues and 500 lines of code, well, it's a look fine to me, right? So people are very easily overwhelmed with the size of the code review, with understanding. They don't have enough time to do it. It's tricky. They don't have enough resources. They don't have enough knowledge about it. So the only thing they can do is either block it or say, well, it looks actually good to me. And this is obviously anecdotal, but there's also research on that shows if you increase the lines of code under review, well, the defect density, so how many defects people find per 1,000 lines of code, decreases. We did a similar study at Microsoft where we also see that the usefulness of comments decreases with the number of files, right? So again, you can use different size metrics here, files, lines of code, changes, adds, deletes, and so on. But you always have very similar results. So we see that actually large reviews are one of the root cause for many other things: low feedback quality, performance issue, difficult to review, time pressure, waiting. So, but it's not enough to say to people, well, have smaller reviews, because the problem alone to make code changes smaller, more coherent, and also self-contained is quite a tricky one. So people have maybe to understand about the single principle, right? And many other things that are going on here. So you actually have to teach people how to do that. And there are some techniques that you can do later on, for example, to split up larger code changes, and you learn tons of it. There is, for example, a very nice Git patch. It's called Git patch. So when you're adding, for example, files, you can, instead of adding the whole file, you can say git add -- patch. You can also use the a graphical user interface to do that. And then you can start and splitting up different things. So definitely you want to separate the refactorings, from feature work, and the feature work from bug fixes and so on. But this can be learned, this can be trained, and it's extremely powerful if people can, in the end, do it. Well, let's say we are doing all of that, right? So we are having small code changes. We are giving enough information. What other things can we do? Well, the third pillar of my secret sauce for successful code reviews is purpose-driven processes. So what are purpose-driven processes? Well, if you look at your code review process, and if you really design it, there are many questions that you have to answer, right? So when is a code change ready for review? Who should be on the review? When should the review take place? What should the reviewers look for? When can a code change be approved? And this information or these answers can be, on one hand, be informed by, for example, evidence that we have, experience that we have. For example, we know from research that 2 reviewers is a good size, but it should also really reflect your needs. What do you want to accomplish? And I'm coming back to this Swiss knife, right? This Swiss Army knife of code reviews, where we have those benefits that we are getting out of code reviews: improved solution, accident prevention, finding bugs. And when I work with organizations, I ask them, so what do you want to get out of code reviews? Why are you doing them? And very often people would say, well, all of them, right? Like, oh, I want to have improved solutions, readability, maintainability, knowledge sharing, and so on. But this is really, really hard to achieve, and achieve in a way that you have a good code review process that leave people happy instead of unhappy. A code review process where you really find bugs, or a code review process where you really mentor and learn. And it also has very much to do with the code change that you're having. So understanding those different benefits and what they mean for the policies is really, really crucial. So finding defects, well, if you want to find defects, you probably have to have at least 2 people on the code review. It also means that you should, have the expertise of the reviewers should be higher than, for example, if your goal is to mentor or teach, right? If you want to mentor or teach, you should have probably as a junior also in the code review. If you want to have awareness, you should have different stakeholders on your code review, but they will look at different things. So what's the focus of the code review? Not every code change will need the same criteria, right? So if it's a very small code change, or in a code-based part that is not so critical, well, the code review process should look different than in a code path that's very risky. It also depends on your development processes, and I will talk about this a little bit later. But in the end, what I also see when I work with organizations is that there are 2 main points. And the main pain points are slow turnaround time and low review feedback quality, right? And so I came up with something that's called the code review quadrant. And so it's more or less plotting the code review speed versus the feedback value, right? And so you can be in any of those quadrants, but obviously it's also flexible, right? So you can be in between, and it can be also for teams different. But so the worst thing is blocking reviews. So you have very sloppy reviews, you don't get a lot of benefits from them, but they're still impacting your development speed. Most of the teams are either in the admissible reviews, so they have they adopted GitHub or GitLab or whatnot, and so they are having this feature there, but they're doing sloppy reviews. Most of them are look good to me reviews, right? They are delivered in a timely manner, but still they are causing some delays. So why do you do them? And the same for value reviews. This is also very frequent that people have they have thorough reviews, but it takes them quite some time to get the reviews out of the door. And so what people want is to be in this power review quadrant part, right? Where you have really high quality reviews, but they are delivered in a timely manner. And so the question becomes, well, can we actually increase the review speed and the feedback value at the same time? Is this possible? Or could it be that if you're doing it, actually this happens, that you have the feedback value goes actually down if you're faster? And so I will give you the answer. This is what happens on the reviewer perspective, right? So, and I'm writing a book with Alberto Pacelli about code reviews, for example. And so if I ask you to review one of my chapters, and please look for, spelling mistakes, proofread it, grammar mistakes, and so on. The faster you are, the probably the worse you find my spelling mistakes. And then I tell you about some techniques very similar to code review techniques, right? And I say, well, if you actually want to find more spelling mistakes and grammar mistakes, instead of reading it by yourself, read it out loud. Because this is a very effective method to find problems, because it tricks your brain. It works a little bit different. And so your brain doesn't just jump to conclusion, but it reads word per word. And then there's another technique, which I can tell you, if you really want to find all my spelling mistakes, or the majority of them, you don't go from the top to the bottom, but you start from the bottom and go to the top. So you read my chapter reverse. You won't, in this technique, you won't understand a lot about what I'm actually saying and can tell me, if there's a good flow in my writing, but it ensures that your brain is reading each word in separation. And so this is very powerful for spelling. But can you imagine how long it will take you? So this is just, and there's actually research on that if we increase the inspection rate, right, the lines of code per hour, we find again less defects per lines of hour, right? But as I said, we don't probably need research for that. We understand that. But there's another aspect of it, and this is, well, we have the reviewer, and now we are thinking about the review, that the reviewer sits in front of the review and does the review. But that's not code reviews. Code reviews is a team perspective or team practice. So it means that there is the person that sends the review, then I receive it, then I have to have time for it, then I'm doing it, then I have all these policies, then I'm discussing with others, maybe there are 3 people on the team, and so on. So if you're looking at code reviews and the speed of code reviews in a different dimension as an organization, as a team, we see that the process speed can increase while the code review value also increase. And I have seen that over and over again. And also this is what Google does. For example, Google knows that most complaints about the code review process are resolved by making the process faster. Right now, and I'm coming back to a little bit the goals, they know that one of their goals is to make them really fast, and they are compromising a little bit on the bug finding capabilities of code reviews, because they have, for most of their reviews, they have only one person, because this means there's less overhead in organization and collaboration, and having both people have time and so on. But they managed to do code reviews within 4 hours average turnaround time. But this doesn't mean that everybody has to be like Google, right? Code reviews should really be the code review practices should really reflect my team resources, time, and scope constraints, and should be integrated. Do I do pair programming? Then my code review should look different, right? Do we work remote? Will also be code reviews will look different than we do something else. What's my testing strategy, and so on. In general, there are a lot of trade-offs to handle. As I said, review time, speed, and rigor. Maybe learning versus expertise, which when we think about reviewer selection. Notification, right? You don't want to overload, but you want to raise awareness, and so on. So I really want to stress this. If you think about your code review process and you design it and you try to improve it, think about the benefits and in which situations you want to get which benefits, and then what does this mean for these policies that you have around timing, focus of the review, how should the review be done, maybe the reading mode, right, the communication schedules, and so on. But even though there is no one-fits-all strategy, I want to leave you with some proven best practices that are actually coming out from research that we did at Microsoft. There are some universal things that you can do to improve your code reviews, no matter how your process looks like. And one is, well, do a self-review. So read through the changes carefully before submitting them for others, right? So this will save a lot of time, a lot of overhead. And there's also research that shows that if the code changes or is already in better shape, you get better feedback. Really have small reviews and learn how to do small reviews. You can do that as a team. There are a lot of different techniques that you can learn how to split up things in coherent and clustered related changes, right? Have low cohesion and high cohesion, low coupling, right? Describe the context. Have, for example, templates for your code review so that people know what they should put into. It's so important, especially also the motivation for the change. Do not just have like a link to a ticket that people should look at. And then invest in training. Set up your engineers for success through internal trainings, through external trainings. Think about the onboarding process. What do people really need to know to be successful during code reviews? Tests, well, have a continuous integration pipeline, a continuous deployment pipeline, and have tests run before submitting the code review. Make sure that they are all green. Have automation in place. And people always talk about the automation, but especially for the code reviews, it's so important to take out those nitpicking discussions, for example, that the linter could already solve for you, that could be automatically corrected, right? Have the right tools. And then you can also think about, and this is like skip or indicate which code review should be done or not done, which I think this came out of this study, but from my experience working more and more with different teams, it's not a black and white. It's not always skip or do the code review, but there is much more nuanced. What do we want to know, or why do we review this particular change, code change, right? Do we want that others know about it? Then we should indicate that, because it means that they will look differently at it. It will also inform which reviewers should be on this code change, right? Or do we want to really, is it a tricky part? Is it something risky? Do we really want to understand, if there are some bugs, and do we want to use code reviews as a bug finding capability, which, by the way, is not the best, right? You should have tests. They are much more efficient in that. But code reviews also find bugs, right? So maybe for this code change, the focus is on finding bugs. And so indicate what you actually want from the reviewers, and also make your selections about the reviewers in that. And I think as a global thing, you should have some templates where and people should know, for this code change, we are doing code reviews in this way. Finally, have crystal clear guidelines and policies that reflect your goals. And this is a little bit what I said, right? So people should know, well, if I have a high risk code change, this is what we are doing. Right? Or if I have a low impact code change, I think it's actually a trivial change, this is what I can do to speed everything up. If I want to have people aware of it, this is how we're doing it. Well, I want to summarize and then really go over to the Q&A. So what I focused on over the last years was really helping teams to increase their review speed, which is so important, and at the same time increase the review or the feedback value. And we can do that by looking at better communication, focusing on the reviewer success, and purposeful driven code review processes. And I want to show you that again, because on the perspective of a reviewer alone, it's really hard to increase the review speed and get more value. What happens is you increase the speed and you get less value, and that's very natural. But if the code author and the reviewer work together, there's actually a speed up. And so this is what I called the focus on the reviewer success and also communication. So if the code author can lend a hand, right? Help the reviewer understand the code change, know what they should actually focus on. Oh, look over here, right? Or this is what I want from you. This is what valuable feedback means to me. Give them context, make the code review small, and so on. Then we see that you can actually speed up the process. And this is not process speed. This is really review speed of one person. So the reviewer will give more valuable feedback and be faster if you provide them with the right set of information. And finally, on this organizational level, on the team level, you definitely can speed up the code review process, and you should take a lot of effort to do that, because we see that if we increase the speed, we also increase the value. Even the same value is more worth today than it is in 2 weeks. Well, this brings me actually to the end of my presentation. I'm opening up the Q&A because I hope there will be a lot of questions. I'm right now writing a book, as I said, with Alberto Pacelli together. There's a little ebook if you want to get that. You can go to this link and download it, where like the code review checklist is also on there. And you can reach me on my website, michaelagreiler.com, or write me an email. I'm also fairly often on Twitter, so I'm always happy to engage in discussions there.
All right. Thank you so much. That was full of information. And because it was so full of information, there's many, many, many questions here. And so we're not going to be able to get to all of them. I'm going to summarize some of them. There was a family of questions that was looking for a comparison between code review and, say, pair programming, mob programming, and testing. What would you say is the strength of code review relative to the others?
Yeah, so I get a question really, really often, and very often it's in a way that people have this opinion or this perception that if you do pair programming, you don't need code reviews, for example, or that one is better than the other. If you're doing mob programming, you don't need code reviews. I think they really are complementary. So you definitely should change your code review practice if you're doing mob programming or pair programming, right? So if you're doing some of those engineering practices, your strategy and your goals that you're following during code reviews should be different than from a team that doesn't do that. But as I said, they are complementary. So for example, just imagine that you're doing pair programming. Very often you have like two people that are very experienced in one code area, but you cannot, for example, get the team awareness. Pair programming also is a very synchronous activity, whereby code reviews is an asynchronous activity. So you can do that while the other person is, sleeping. And especially in our, transforming world right now, I think code reviews really offer a lot of benefits for teams that, for example, need this asynchronous communication or want to use it. And it's also, I think it plays a little bit to the strengths of different personalities. There are definitely people that, love pair programming more than code reviews because they're doing it together. And for others, it will be like, it will take them a lot of energy to do pair programming, not even, mob programming. I know really a few teams only that do that on a constant basis. I know some, but most of them do it like occasionally, like, Wednesday we have like a pair programming session, or now we have one if we need it, whereby code reviews can ensure that your code changes, have a specific quality or meet a specific quality bar on an ongoing basis. So I think it's a very interesting question. But if you're looking at the goals that you're getting out, depends also how you structure your code review process, they are complementary. So I think they go very well together. And hope this answers the question.
I mean, one of the techniques I should have included in that last question, maybe you have a couple more sentences to add, the use of static analysis tools. So if you use a static analysis tool, do you do code review as well?
Oh, yeah, definitely. I mean, I would say the other way around. I hope you're not doing code reviews to find static analysis errors, because this would be not very good for your resources, for the effectiveness of your efficiency, right? So I definitely encourage you to have static analysis tools, and the best is to have that as a team effort, so that the configuration and pruning, that you don't have like false positives, too many false positives or false negatives and so on, is done as a team effort, and that everybody can benefit from that. But this should be part of your code review process. And ideally, this is done before anybody looks at the code review. And what we also see, there's, for example, a study at Google where they had like 3Coder, and they were running it during code reviews or before code reviews, right? As part of the code review process, the first step, you got like pod comments, for example. And we see what they saw is that a high percentage of those comments, of these static analysis problems that were detected, got fixed. But then in a different group, they had that after the merge, right? So people could already check in their code reviews or the code changes, and then later on 3Coder was reporting those errors, and people were not fixing them, right? And so they were not fixing less of them, they were just not fixing those issues. So if you're doing something like this, it's really beneficial, and you should have it as part or as a pre-step to do code reviews.
Great. And so there's another family of questions around efficiency and overhead. So what would you say about teams that do code review? Like, what's the overall cost of it versus not doing it?
Well, this is really, really difficult to estimate. I'm actually writing right now a blog post about the return of investment on code reviews. It's not completely finished yet. But so I think that there are a couple of considerations that you have to keep in mind. The first thing is that, well, and this is long time ago, actually, at Microsoft, the engineers were spending on average 6 hours per week on code reviews. And I think this number definitely went up. And so, yeah, it is definitely a very, time-consuming practice. But the question is, what do you get out of that? So you have, on one hand, you have like the cost when you think about, and I actually wrote a paper where we looked at testing, and it's called the art of testing. And we looked at Windows, and the test cases were really taking a lot of time. And so we wanted to know, can we actually reduce the test cases that are run on the Windows system and still have the same quality? And I think what I really would like to phrase is code reviews in a similar thing. So what are the costs that are going in? Well, it's the people's time, right? So people have to sit and do the code reviews. And then you have to think about the benefits that you're getting out. And we know that, for example, if you think about a bug, right? If you look at the bugs that are found during code reviews, they are they are less expensive to fix during code review than they would, for example, be during production. Even with continuous integration and continuous deployment, where we can ship, very frequently, if we can do it, the bug is still quite expensive if it's found in production or after code review, and it's less so during code reviews. And then you have to also think about, are people, the awareness that you're getting, right? What does it cost if a person leaves and nobody else knows about the code part that they worked on, the code base part that they're working on? And so I think there is no general answer to that, but there are ways to analyze and get a clue about what's happening in your organization, right? Do we actually meet our goals? Do they have more awareness? Do they find issues in code reviews? What are some of the issues that they are finding? Do they learn? Do they, what about the mentoring? And I think one of the best questions to ask here again is, are people actually satisfied with their code review practices? I think this is a very good indicator for if the return of investment is high or not. If they're not satisfied with it, something goes wrong, right? So maybe they're waiting too long, they're not getting the feedback back. So I think for a lot of people, the return of investment is actually quite low. But it doesn't mean that it has to stay this way. You can actually increase the return of investment by changing some of your processes and things, how they work. Yeah.
Yeah, thank you. So there's another family of questions around just like the interpersonal aspects of it, people being defensive. Like how can you help people from being defensive and looking on the positive aspects as opposed to being defensive?
Well, I think it's very natural that people are defensive, and I think these are those two perspectives. I think the main part is starting with awareness for both people, right? The author and then also the code reviewer. The author really worked a long time on this code change, and I think I cannot imagine a person that wants to push bad code or wants to push a bad, solution, but they have a lot of constraints that maybe you are not aware of. So whenever you are a reviewer, you have to be also careful about jumping to conclusions and coming in with your great solution for a problem that actually the other person is an expert on. And a lot of things can be improved by phrasing your code review feedback in a different way. So in my workshops, for example, we really go, I have a lot of different examples, how you can rephrase it. And what I see over and over again is that if people then apply those to their own feedback, they see a lot of different things that they could phrase in a different way, in a way that doesn't bring the other person on this defensive on the defensive side, right? So instead, for example, to say, oh, you requested the service multiple times, you can make it about the code. This code requests the service multiple times. And so I know that it's working because I work with a lot of organizations that, I start with a team and then I have another team. And so you can really see that over the time that you're starting to work with more and more people and these rippling effects, that people understand that the code review feedback that you're given, it has a lot to do with how you phrase it, becomes more and more inviting for discussions and, less aggressive. And therefore people can also get it or accept it and request it in a more interesting way. There's also a really nice book about it. I forgot the name, unfortunately, but it talks about instead of, pushing feedback, it's better if the person are pulling, right? So in code reviews, you can also change a little bit the mentality that people that are asking for feedback, they guide a little bit the code reviewer, telling them, oh, I want to know something about this aspect of the code base, right? Or I'm sending you because of, and this is again coming back to the goal-oriented perspective. Right.
All right. Well, I appreciate very much the presentation and your answers. I'm afraid we ran out of time. I also appreciate the interest and participation on the part of the listeners. Unfortunately, we probably got to 5% of the questions. But it shows how much you're interested in the topic, so I appreciate that. This talk was recorded, and it will be available online in a few days at learning.acm.org. Some of you are asking that in the questions. You can also find announcements on upcoming talks and other ACM activities at that site and also at acm.org. Please fill out our quick survey where you can suggest future topics or speakers, and you should see that feedback on your screen. So on behalf of ACM, Michaela, and myself, I would like to thank you for joining us, and I hope you join us again in the future. This concludes our talk, and I hope everyone also has a very happy holiday season. Thank you, Michaela.
Yeah, thank you so much. It was really my pleasure. I enjoyed it a lot. People can ask me questions on Twitter if they want. I will answer in an asynchronous way, but I will answer if they ask me.
Great. Thank you so much.